Hi, I'm here today to talk to you about SQL injection attacks and what they are, how they work, and most importantly, how they can be prevented using defensive coding. And to put it plainly, SQL injection is when an attacker puts together their own special query that is then sent to the database by putting it into an input field in any web application. Once inside the database, it is then used to retrieve any information it wants. This is done through various methods of SQL injection. One particular method which I'm going to demonstrate to you now is a tautology attack. To put it simply, a tautology attack means that whatever query the user sends to the database, it is always going to be true, therefore it is always going to retrieve some form of information. And in this case, I'm going to show you how a tautology attack can be used to trick a database into thinking you've given a correct password when actually you haven't. So for this purpose, I have already created a user called Jane, and the password I have created for her is password123. Just to verify that this works, log in, and here we are, Jane. And in this website, you can simply post messages to a database, and then once you post them, you should be able to view them here. So I'm going to log out, and I'm going to redo this. And just to verify that the login functionality works, I'll put in the wrong password first. I'll put in password. Invalid username or password. So we've proved that if you put in the wrong credentials, it's going to come back with an error message. However, using tautology attacks, that can be prevented. So here I'll just show you the statement that we're going to use: an or 1 equals 1, and then a hashtag. So or 1 equals 1 in any code base means always true. So the way this is going to work is we're going to send the username Jane to the database, and we're going to send this query to the database. So the logic that it should come true is check if there is a user called Jane, which there is, and then check if there's a password or 1 equals 1 bracket hashtag. Except there isn't going to be a password like that. However, this is going to be viewed as code, which means it's always going to return true. So it is going to think that we've supplied the correct password. Now, let's see if this works. Voila. I'm going to go into the code to show you how this is broken down. So here we have the simple statement, which is just select from users where uname equals username, which is the username supplied by the user, and p-word equals password. Again, this is the password supplied by the user. So we use a simple statement that creates the statement. It then executes the query. If correct, it'll send you to the home page. If not, it'll display an error message. Now, as explained before, when we put in Jane is then put into this piece of this code here, and when we put the password or 1 equals 1, that is also put in there. So logically, we have tricked the database into thinking that we've supplied the correct password, when actually we've just told it that whatever I put in here, I'm gonna be right. This is quite similar to Star Wars: A New Hope, when Obi-Wan Kenobi tricks the stormtroopers into thinking that these aren't the droids you're looking for, when in this case, this is the password you're looking for. Now, if we go over to code that can prevent this, which I've implemented here, validation. So here we have the same statement. However, we're using question marks. Now the question marks are unnamed parameters, and they're implemented using this, a prepared statement. Now what a prepared statement does, which puts it away from a regular statement, is it compiles the actual SQL statement here before it is sent to the database to check if the user has given the correct, the expected input. So for example, a username should be a simple text-based name, and a password should again be a simple text-based name. And if it finds code, it won't send it. And here we have setString. Again, setString sets the user-defined username and sends it into the first question mark, and then same for the password and sends it in here. Now if we use the tautology attack and put in Jane here and or 1 equals 1 here, it'll first execute and it will see that we haven't supplied what the statement is expecting because it's found code, and therefore it will not be sent to the database, and which means that the attack won't work. Now just to verify this works, we'll run this particular web application and just prove its validity. So I'll just register the same user, Jane Doe, janemail.com, Jane, and we'll use password 123. Submit. Now we're successfully registered. So we'll just verify that that password worked. Just pasting the same thing I did last time. Happy days, we're here. We'll log out, and now we'll see, can we hack into this website using a tautology attack. So we'll copy the same script here. Log in, invalid username or password. So what has happened here is the SQL statement select user where username equals question mark, password equals question mark has executed before being sent to the database. And seeing as password as the or 1 equals 1 was seen as code and not a valid password type, it was not sent to the database and therefore could not trick the database into thinking it was given a correct password. This tautology attack was all avoided thanks to a simple defensive coding technique called parameterized queries. You can learn more about this by studying the slides and seeing in Hack the Hacker the educational tool for web-based vulnerabilities. Thanks for watching.